DevSecCon. I'm really excited that you're here to join my session today. And today we're going to, well, play a game. Of course, we're going to play the classic game of I Spy. If you haven't played this in your car on the way somewhere, or if you haven't read some of the books, well, we're going to try to play a game with an insecure delivery pipeline today. So, as I mentioned before, let's play a game of I Spy. But who am I? I'm your host, Rosemary Wang. I'm a developer advocate at HashiCorp. I like talking about infrastructure security, and DevOps. If you want to learn more about me, feel free to reach out to me at any of the handles on this slide. All right, I mentioned before, we're starting with a delivery pipeline. This delivery pipeline is focused on infrastructure delivery, but any pipeline will pretty much express a workflow for applications or infrastructure to go to production. I like focusing on infrastructure because it often provides a lot of interesting perspectives from a security standpoint, and it's one that a lot of people don't necessarily think deeply about. So this is an infrastructure pipeline. It's using Terraform to format, initialize, plan, and apply an infrastructure configuration to production. In this pipeline, I've got a couple of stages. The first is a unit test. The second is build. The third is deploy. There's another test stage for integration testing or end-to-end testing. And then there's a release stage. The release stage applies the configuration to production. If you're not so familiar with infrastructure delivery pipelines, that's okay. The idea is that this pipeline is representative of some of the more generic pipelines you might have, whether you're deploying an application to any kind of workload orchestration, or you're deploying any sort of infrastructure to your cloud provider. In this game, we're going to try to spy three things. The first is a password, the second is a public endpoint, and the third is a possible misconfiguration. As we walk through some of these I Spy targets, what we're going to identify are ways that we can do it better as well. So the first thing is, let's spy a password, public endpoint, or a possible misconfiguration. All right, let's start with my infrastructure pipeline. My infrastructure pipeline takes an input. The input involves a database username and database password. Now you might be thinking, why would someone pass a username or a password to a pipeline? Well, if you're doing something like infrastructure as code, you're trying to express as much configuration as possible in version control. So it's pretty natural to pass a username and a password to any kind of middleware component, whether it be database, cache, queues, or otherwise. You want to make sure that, well, someone knows whether or not these usernames or passwords changed, and you want to manage them immutably. So as a result, you'll pass them as part of your pipeline. But here's the problem. Do you spy something that's not right with this configuration? I'll give it a moment. But I spy a database password. This is actually a pull request that I extracted. I made this mistake a night before a demo. I realized that my pull request prints out the plan of my infrastructure configuration and output the database password. I was in shock. I really was not sure what to do at this point because I only had about 8 hours before I had to demonstrate this live. And so I basically decided to go with my favorite plan, which is Plan R. And it's not just my favorite plan because it's the first letter of my first name. It's my favorite plan because literally I go through this process every time I accidentally compromise some credentials. So the wonderful steps of Plan R involve regret everything. The second is revoking the database password or the secret that you've compromised. The third is rotating it. The fourth is referencing it and finding wherever you've referenced it. The fifth step is replace. Find and replace is your best friend during Plan R. And the sixth, especially in the case of pipelines, is rerunning everything. When you define a database password and username like I have statically, you need to rerun every pipeline that references it. You can't leave the pipelines as they are because you're already running some infrastructure or application in production that's using the old password. So Plan R is fantastic, except it's really difficult to implement at a large scale. It's also very difficult for an operator or an engineer who has to execute upon it because it's predominantly manual. So how can we do this differently? Well, let's think about masking the database username and password. And we take this for granted, right? In the application space, you might think about masking the database username or the database password in logs or even in your pipelines. But in infrastructure, it's easy to forget to do this. In Terraform, there is an attribute called sensitive true, which will identify and mask any instance of the variable that you're passing in. And so if I add this to the pipeline, which I did, what it will do is redact any of the sensitive information that I've predefined. So for example, I define my connection URL as sensitive, or portions of my connection URL as sensitive, and now it does not print the database password and username into the pipeline at least. So this made me feel a lot better. I did keep the PR open for posterity, so if you want to take a look at it, you can. The password is no longer valid. It has been rotated, but the idea is that I wanted to remind myself to at least make sure to mask that information. So Plan R is actually something you can improve further. The problem with Plan R is the revoke, rotate, reference, and replace steps. These take a lot of time. Not only should you be masking your secrets and protecting some sensitive information in your pipeline, but you also want a really easy way to remediate them automatically. And the solution to this is usually to use a secrets manager. Secrets manager can be a little bit difficult to set up, but what it will allow you to do is automatically rotate the password, and you'll be able to replace everything, but with the reference to the actual secrets manager. So if you're already retrieving secrets from a secrets manager, your pipeline just needs to be rerun and just grab the new secrets. So there's really nothing that I have to do manually, which makes me pretty happy as well. So in terms of this process, I probably should have put the password into a secrets manager and actually rotated it within the secrets manager rather than hard coding and passing it through as a static variable. All right, so we've spotted a database password, but what could we do even better? Well, we can take our pipeline and build steps to authenticate to a secrets manager, retrieve the secrets, and ultimately verify whether or not those secrets have been masked. So this is a pipeline configuration that I've put together for this particular pipeline that deploys to AWS infrastructure. What I've done is added a step within the pipeline to authenticate to the secrets manager, retrieve the secret, and ultimately inject it into the pipeline. So this is a list of secrets like my AWS access key, secret access key session token, other tokens, and I'll inject that into the pipeline. What's important to recognize is that there's actually two sets of secrets in an infrastructure pipeline. The first is that database username and database password that I added in as variables to create the infrastructure. But there's also secrets that you have that you need to access infrastructure providers. This is like your AWS access key, your Azure service principals. There's two separate secrets. And so if you manage both sets of secrets within a secrets manager, it makes it a lot easier to manage both across all of your pipelines. I spy, instead of a database password, a secrets manager in this pipeline. And it makes it easier to issue the credentials for each pipeline run. So anytime your pipeline executes or needs to run again, it will retrieve the new credentials from the secrets manager. You don't have to go in and redefine them or change environment variables. You also manage the access to the secrets. You can manage the access per pipeline. So each pipeline gets their own path, for example, in the secrets manager to retrieve the information that they need. You also get one place to audit the usage of the credentials. Within a secrets management store, it usually offers some kind of audit logging. So you can take a look at all the credentials you're using and when they're being used and which pipeline. In this case, I am using a delivery pipeline. So you may not spy secrets in applications in your delivery pipeline. You might actually find them in application logs, as I mentioned before. So I would say that this kind of approach is definitely a thought that you should think about improving for infrastructure delivery pipelines and application pipelines, and don't usually include these secrets. They're usually dynamically configured or retrieved by applications. Okay, so we found a password. Let's spy the other two, a public endpoint and a possible misconfiguration. So let's take a look at our pipeline again. Recall that I've added a step in my pipeline to import the secrets from my secrets manager. In this case, I'm using a secrets manager called Vault. This architecture involves a couple steps. The first is that the Vault server needs to have some kind of authentication in front of it. So what GitHub Actions, which is my workflow, my pipeline workflow orchestration, is going to do is authenticate to Vault server first. And this is so that it can actually retrieve the secrets later on. Then what it will do is retrieve the secrets and run any infrastructure configuration it needs to do. So in this pipeline, remember there was a release stage. GitHub Actions needs credentials to do the release. As I mentioned before, 2 sets of credentials. In this case, this set of credentials is used to create infrastructure. Do you see an issue with this connection, specifically between my CI framework, my continuous integration framework, and Vault server? Well, I spy a public endpoint. And this is one of the most, I think, the most shocking kind of at least interfaces that you'll have between your continuous integration framework and a Vault server. If you run your own on-prem integration framework, this usually isn't a problem. You at least have some kind of trust mechanism within your own internal network. But as we move to more managed continuous integration frameworks, we're doing this over public endpoints. You don't have any real way of connecting to a managed continuous integration framework over a private endpoint. There are exceptions though, so we'll talk about those. Well, with public endpoints, there's a couple of solutions that you might have from a security standpoint to fixing the problem of a public endpoint. The first is to shorten the time to live for secrets. Shortening the time to live for secrets means that rather than allowing the secret to be around for 6 months, instead you change the secret every 30 days, something like that. The other possible solution for public endpoints is to only allow IP addresses from the continuous integration framework. If you're lucky, your continuous integration framework offers a list of subnets that they'll commonly use. However, with most CI frameworks, they'll actually shuffle the runners around different subnets. So there's no guarantee that you're going to have the static subnet that you'll be able to allow from whether it's from your continuous integration framework to Vault server or secrets manager or whatever private endpoint that you're supposed to have. So there's no guarantee there. The final solution is to use self-hosted runners, and I think this is probably the better solution. And in general, what this means is that you create a runner in your own network, and the public CI control plane will be able to communicate with your runner and then run jobs on your runner. But there are some caveats to all 3 of these, right? When you shorten the time to live for secrets, do you really want to change your database password every 5 minutes? Not necessarily. It means that you have to re-authenticate every time. That could add some performance problems within your application or your infrastructure. On top of that, only allowing IP addresses from continuous integration frameworks isn't really necessarily least privilege, right? If a CI framework changes their subnet, IP address ranges, you have to change as well. Finally, self-hosted runners also come with their own security management concerns. You have to make sure that the pipeline isn't going to run and inject some kind of malicious code on your self-hosted runner. So in this case, we'll go through the 3 solutions, but the first in this implementation is fixing the least privilege problem. One way you can fix the least privilege problem is adding basically the secure access management tool in front of it. So in this case, we could add something like Boundary in front, which you would register the public endpoints that you have available. In this case, I'm registering, let's say, a database and a front end. I register it to the controller, and ultimately the pipeline or the CI framework will authenticate to the secure access management tool and then proxy through the secure access management tool to different endpoints. So you're controlling one proxy that allows all this to happen from your continuous integration framework. It's still public, but you're able to control, authenticate, and identify any open sessions from the pipeline to any of your important endpoints. So in this case, I am going over a private network to connect to my secrets manager, and this allows me to do that. And I can successfully retrieve my secrets through the proxy. The second option, or the second solution that I mentioned, was using the self-hosted runner. In GitHub Actions, which is the tool that I was using for this pipeline, you can create the self-hosted runner within your own private subnet. And the self-hosted runner includes some kind of agent for secrets manager or your private endpoint. GitHub Actions will use the self-hosted runner to start the job. And the self-hosted runner has the ability to authenticate to the private endpoint as it sees fit, right? So in this case, in Vault, you can set up authentication methods to go through using AWS identity to authenticate to the Vault server. But if you're using some other kind of endpoint, you can use any of the other authentication methods, and you would have that on your runner, embedded on your runner. So it makes it a little bit easier. And finally, that allows you to retrieve the secrets onto your runner. So in some ways, this is some people tell me this is the more secure topology, although there are some concerns, right? You do have to patch your runner. You have to make sure that no one's going in and injecting any malicious code. You have to control the access to it as well. And finally, self-hosted runner has the ability to make changes to your infrastructure. So keep that in mind as well. Anytime you add any access to your runner, then it may have expanded privilege to do something in your network or in your infrastructure. But in some ways, this might be a better topology if you're trying to secure your public endpoints. So what are we really spying, right? Rather than spying a public endpoint, what we're doing is we're adding access control to this pipeline. We're able to proxy and audit the access to the different endpoints with secure access management. And we can also manage and control our own runners. By proxying and auditing the access itself, we're able to get closer to some kind of zero trust model, not to say that it is 100% zero trust, but what we're able to do is at least audit and identify the sessions and connections based on the pipelines as well as the target infrastructure. Okay, so finally, we have our last I spy. Our last I spy is a possible misconfiguration. I added the entire configuration for the pipeline that I've been using. This pipeline has a couple of jobs and some steps. So if you're not as familiar with GitHub Actions, which is what this is written in, don't worry about it. The idea is to focus on some of the steps. You'll notice there's a couple steps, including importing secrets, setting up Terraform plan, and getting some status and apply. Well, do you see anything wrong with this configuration? Well, I spy one thing wrong right off the bat. And that's the pull request branch here. So basically what the configuration is saying is on a pull request, run a Terraform plan. So show me the dry run output of my infrastructure change. Then when I merge to main, apply. But what happens if someone removes the if statements from here? There's nothing stopping someone from deleting the if statements out of this pipeline configuration. And that's a possible misconfiguration in some regards. Because what happens is that if you delete the if statements, it means someone can go push anything to production. So if I deleted the if GitHub ref main, anyone can push anything to production. It auto approves to my infrastructure. This is actually a big misconfiguration issue because it's pretty easy to accidentally delete a line. It's not to say someone's going to do this on purpose. Most of the time, people are just trying to make the edits, and sometimes they'll delete something because they forget that it exists. There's actually a second possible misconfiguration as well. And those are the steps here. The big question is, how do you know that these GitHub actions are secure? We don't know where these plugins are coming from. Now, some of them are verified, but others are not. So is it okay to use these plugins? Do they have some kind of malicious code injected in them? And that could compromise our delivery pipeline? Well, we don't know either. And so there's two possible misconfigurations. When you do this I spy exercise and you check your pipelines, understand there are multiple exploits that you can have in these pipeline configurations. First, when you have a pipeline configuration, it's often mutable. It means that you can change it in place. Second, well, someone can actually go in and add some remote code and execute it on any of your runners or any other, pretty much any kind of runner that you have interfacing with your infrastructure. This is something that I discovered the hard way when I did find a Bitcoin miner on our CI framework at one point. This was a separate opportunity, but the idea is that we didn't really know that there was a possible exploit, and this did happen. So the other thing is that unverified plugins, right, are possibly subject to supply chain attacks. This is something that did happen in some of the HashiCorp pipelines. It was remediated. It only compromised one set of things, which is the GPG keys. But other than that, it was remediated fairly quickly. But the idea is that insecure pipeline configuration is something that you might do by accident, but it has some real consequences to it. So rather than wait and potentially kind of let these misconfigurations sit in your pipelines, try some policy as code in the pipeline. What I mean by policy as code is automating the policies to check pipelines and their outputs, right? So you implement some kind of policy as code, often to check misconfigurations in your infrastructure. Why not use the same policy as code to check pipelines and their outputs? So use pipeline as code to enforce the stages. Rather than allow everyone to use the same YAML files, copy, paste, and edit it themselves, you want a balance between getting the right kind of pipeline templates in place so that people actually know the stages in the pipeline that they need, but also have the flexibility to add new things if they need it. Second solution is to audit your pipeline logs for possible issues. So this was actually something I learned. You can audit your pipeline logs for any kind of unauthorized commands, possible privileged commands that someone is executing within your pipelines. This happens more often than not. Some folks are just need a database password, for example. So they may go in and they may edit your pipeline to print out the database password so they can use it for some break glass scenario. That is not something you should be doing. But that is why you have some kind of audit capability. Make sure that you're actually checking for any outputs or someone's going in and getting that information. Finally, verify plugin checksums. This is something that is really helpful to ensure that you're using the right plugins and the plugins that you're planning to use haven't been compromised in some way. Also make sure that you are using your a verified plugin, so scan it, make sure that it's actually something that you're allowed to use in a pipeline. Open source is really powerful. There are a lot of fantastic plugins that will help you, but keep in mind that you can't necessarily be certain if they won't compromise a secret or credentials in your pipeline. And if they do compromise secrets or credentials, hopefully you have a secrets manager in place that helps you execute Plan R very seamlessly and as efficiently as possible. All right, so we played this game of I Spy. I think we spotted all three. There are probably more, so I'm sure if you have any other things that you've spotted and you would like to point them out, feel free to let me know. But we've spotted all these three things, and well, at the end of the day, the hope is that you are able to spot some of these more general things and make a more secure delivery pipeline. So rather than say that you have a potential password that's going to be printed out, or you're accessing things over a public endpoint, or your pipeline has a possible misconfiguration because someone accidentally deleted a statement in the pipeline template, well, implement a couple things. First, secrets management, second, access control, and third, policy as code. Implementing some of these practices will help give you a more secure delivery pipeline, and you'll at least have the opportunity to remediate and fix anything should there be some kind of issue with your pipeline. Now, if you have any other questions, you're always welcome to reach out to me at this handle. And you're also, if you would like the slides and potentially some of the demonstration code that this presentation was based on, you can also check it out at joatmon08.github.io. Thanks for joining my session today, and enjoy the rest of DevSecConf.